All right, here we are on the 9th. So we are on Section 3, Week 4, and this will be Video 1. This will be the only lecture this week. And we will have a quiz this Friday. Here's the study guide, which just covers the major themes, concepts, scripts that you need to know about from these videos. And just to wrap up first person shooter, I think we're just going to cover the weapon prefab, one of the projectile prefabs. This probably would just be like an enemy weapon and maybe one player weapon because there's like 3 player weapons and probably two. There's 2 enemies. I'm guessing 2 weapon prefabs for enemies. And looking at one of the scripts, one of the simpler ones. And then we'll be all wrapped up for first person shooter. And so if we continue our, since we were digging into the hoverbot last class, and we basically covered everything that's at the root here, and we started to dig down into the weapon root, into, here we go, weapon laser eyes. And we have this weapon controller here, and audio file. Let me just, I just want to double check that enemy turret. If we dig down, health bar, pivot, hitbox, damageable, turret top, skin mesh renderer. Just hunting around for its weapon. Maybe did they throw it right at the top since it's kind of a different. Oh, it's probably deep in its little root structure. Here we go. Weapon root and weapon machine gun. Okay. And still has this projectile turret. Alright, so that's the turret. And I just want to quickly look at the player. I'm going to guess that there's no weapon controller script that just sits on the player because they get weapon prefab spawned. And so I'm going to guess that the weapon controller is going to be right on the weapon for the player. So let me see if there's like the first weapon prefab spawn. Weapon, player weapons manager. Okay, starting weapon, weapon blaster. All right, let me just throw that. So he's got blaster, launcher, shotgun. Let me just look at blaster real quick. So blaster has a weapon. Okay, here's the weapon controller script. This is what I was interested in looking at. So where this weapon controller script sits right on the hierarchy of the 2 enemies, this is connected to a weapon prefab for the player, and there's a few weapon prefabs. Fuel cells, overheat behavior. Okay, cool. So we've looked at the weapon controller script for the hoverbot. I mean, they're all sharing the same weapon controller. And we went through this script quite a bit. And now let me see. Remember I said after everything. So for example, with the enemy hoverbot, after all those managers are doing stuff, communicating with each other, eventually, if they fire, they're gonna fire a projectile hoverbot, and then here's projectile turret. So after all those kind of enemy manager scripts and communicating along with the weapon controller, if there is a successful fire, ultimately this weapon hoverbot and or this weapon, this projectile hoverbot or projectile turret is going to be instantiated and released. Like all the responsibility at this point from the enemies are done with, and actually from the player's perspective as well. They released this projectile prefab, and here's what the enemy ones look like. Look like they're pretty much exactly the same. The looks like Hoverbot's got a higher damage, and it's just like the root. Where is this coming from? Either the turret. Interesting that oh, I see. The turret is a machine gun, so it fires many projectiles within the same time frame as like one projectile for a Hoverbot. That's why it's less damage. But that's the only differences between these two. But if you open up the prefab hierarchy, you can see that we kind of have this prefab standard script sitting on top. And then we have the mesh projectile. So we've got the mesh render and the material here. And then the tip of it is just like an empty transform. We're testing if it hits something or not. So projectile standard, there's projectile charged, but projectile standard is going to be like the standard, the base class almost for, this is the base class, I should say. But, this will encapsulate most of the behavior of all these projectiles. All right, so we have a bunch of properties. Radius, where's the root, where's the tip, how long should it be alive for, kind of similar to VFX. VFX to spawn upon impact, lifetime of the VFX, clip to audio to play, which physics layers can we collide with, how fast is it moving, should gravity affect it, should we be inheriting the core weapon, like I guess inheriting weapon velocity, if the player's running around or something, should the bullet inherit that velocity from the weapon? Looks like normally not. Damage, is it an area effect? And so here we have some fields. And trigger query interaction overrides the global physics. Okay. So we're not going to have to worry a bit too much about this, but you can like do a bunch of settings of your global physics settings, and then sometimes you can create your own kind of custom physics queries, and this happens to be one of them. So on enable, go get the projectile base. Okay. So basically, get itself. Let me just make sure there's nothing else. Yeah, get itself, but get a reference to its parent. Or maybe it's like all the projectiles are inheriting from projectile base, so this just gets whatever component it happens to be. Doesn't matter if it's projectile standard or if there's other ones, say energy weapons or what have you. This here. So on shoot, we're going to listen to it. It's kind of annoying. So if I jump into here, projectile base, which all these projectile scripts are inheriting from. So we have like the owner, your initial position, direction. We'll have like initial spots, but notice here there's this event, there's this Unity action called on shoot. And so basically all this, whatever projectile is inheriting from this base class, it'll inherit all these properties, it'll inherit this event. So it's like these are all standard things that a projectile script needs to have. And then there's this this shoot public method. It's going to receive a reference to the weapon controller that called it. And so whether the weapon controller is sitting on the enemy prefab hierarchy or whether it's sitting on a weapon prefab on the player, it's going to be the weapon controller that's going to call this shoot on this projectile standard after it or projectile base after it instantiates the projectile prefab. And then it kind of does all these settings, and then if anyone's listening to this, it invokes that event, which is a little weird because the child class actually puts a listener on its parent class's event, and so then this child class's event listener will get called. So it's just like saying, hey, all the projectile scripts will definitely run all this stuff, and if any of the child classes have like additional methods, I'm going to call my event, and if they chose to listen to it, they can call their own methods. It's kind of weird set up in parent-child classes like this, or in inheritance. You're supposed to like not overwrite this method, but kind of add to it. If this is like the parent method, you can either overwrite or add to it. But basically, it's a little weird. It's like saying, okay, here the method's going to continue on here. So the child, the projectile standard class, will continue its own custom logic here after that kind of parent class ran its own like shooting logic. But anyway, that's what this big whole thing is. And then it looks like there's an update method. And is hit valid on hit. And we do some debug drawing. So what happens on shoot? So this base class is just inherent, like it's getting its initial position, direction, velocity, charge, all that stuff is being set. Whoever the owner is, okay. And then we continue on here in projectile standard. So the shot time, whatever the current time is that the app is running. The root position. Okay. Transform representing the root. Okay, so this is like one of the children game objects. It's telling us where the root is. Velocity, a new list of colliders, and these are what we can ignore. Then it looks like we add, adding a range means add this list, which is already a list, the owner colliders, add it into my other list. So it's basically whoever was the owner that fired this, we're going to ignore their colliders. And then take the projectile base inherited muzzle velocity, which I think we're ignoring. I think those set to false. But anyway, you said like wherever our position is now, let's add the initial velocity of the muzzle since the person was like running or whatever, and like let's place it a little bit ahead so like the bullet doesn't spawn inside the player or whoever fired it. Then ignore your own colliders. Sure. So make projectiles not go through walls, and remember center of screen trajectory. All right. So get the owner of the projectile base and get a component. See if there's a player weapons manager. And if there isn't, this came from the enemy bullet, then we could skip this whole if, and then we're done. But if it did come from the player, it looks like we don't want the, I guess these things move so fast, and if you're right up next to a wall, maybe the projectiles go through walls was like a common scenario they found. So it looks like we're doing some correction vectors, project on plane. I've covered that with you. Some correction distance, and then do a ray cast from the player's weapon manager weapon camera position out to the camera to muzzle, so that so it's normalized is a direction. So wherever like the player's camera pointing to the muzzle, we want to normalize vector to there. And it does the distance, like how far out from the camera to the muzzle, and if there's a hit on hit. Okay, so we do have on hit. On hit. Okay, so it looks like on hit should be like a real hit. So if, okay, I missed this. If is hit valid. So we have a on his hit valid. If whatever we hit has ignore hit detection on as a component, just return false no matter what. Okay. ignore hits with triggers that don't have a damageable component. So remember, the colliders can also be set as triggers. I'm just checking the level real quick to see, like, do they have... Okay, every part of the level has a collider on it. And it's not... Triggers you can, like, walk through. Triggers are more like volumes of space. You want to know when a player enters a volume of space. You don't want, like, 2 colliders to hit. So when you want a situation like that, you just make it a trigger. It's like a passive collider. But I just wanted to check if, like, on a wall, is there a certain script, like, do not hit or something. As far as I can see. All right. So other ways, if you've hit a trigger and it doesn't have a damageable, just return false. These are some ignored colliders, self colliders, return otherwise. So if these situations are all false, whatever the collider is that we're processing with the bullet, then return true, like it's a valid hit target. And so if it's true, I'm up here. If it's true, then we go to on hit. And on hit just says whatever we hit, the location, the normal, and the collider of whatever we hit goes into on hit. And then normal point collider. So if it's area damage, which is false, it's just a normal bullet, so we don't do that. So whatever collider we just hit, see if there's a damageable script on it. If there is, then we can call inflict damage on that damageable script. Otherwise, false and nothing happens. Like, we hit it, that's great, the bullet explodes, but whatever we hit wasn't damageable. So just right now, enemies and players have the damageable component attached to any game object that's got a collider on it. And last time we did like a mod where, you know, we added damageable scripts onto the environment, gave them some health points, and you could eventually blow up walls and walk into like hidden areas. Anyway, if there's some impact VFX, play that. Some sound effects, play that, and then eventually just destroy this, the projectile. So this projectile prefab. Just know that this is for projectiles in particular, we should really be doing object pooling. You shouldn't really be instantiating this many game objects and destroying them. It's very expensive. It'll slow down your game. For projectiles, you should really give everyone like a pool. And they can recycle them and like turn them off when they're not in use. So for somebody who's got like a single shot laser pistol, like enemy hoverbot, maybe he only needs like 3 like in his pool, because he fires and he stops and he fires again, so that bullet will be destroyed by the next time the other one comes through. For the turret, it depends what, like, how many bullets are on the screen, but if he's like just shooting all the time, he might need like a pool of 50 or something. But just be aware of object pooling. In either case, update. So in update, take our current position, add our velocity vector times the change in time. Because remember, every update is a little frame, and so delta time tells us that little bit of fraction of a second that just happened since last frame. And so that's how we get nice regular movement, independent of the frame rate. So anyway, whatever our velocity is times a little point of second that just happened, let's add that to our position. This is what actually makes the bullet move. And it's going to move really fast. And you could slow, if you wanted to, you would pass in a slower velocity if you just wanted to watch it move very slowly. This one was set to false, we can ignore that. So drift towards trajectory override. This script happens to actually have some good comments in it. The other ones, like I said, to kind of figure out from the code. And you can see the importance of commenting. Let's see. I don't really think drift towards trajectory override. That cannot be centered. All right. So something that correcting the trajectory so it looks better. Or acts better. Not really worry about it. So orient towards velocity. So get the velocity and normalize it. And okay, so whatever your velocity when you left, you can normalize it, and that'll give you like the direction that the bullet should be moving. And what this is saying is they probably did some corrections, yada yada yada, but they still want to make sure that the bullet is facing locally forward. So transform.forward is like it's local forward, not the global. So however much it's rotated or oriented, whatever it's local forward, the z-axis, that's what forward means. And this is like saying, hey, well, we remembered what the velocity was when we first fired this bullet. We just did a bunch of corrections up here, so let's add that. Let's make that normalized. Make it like it's just a slight tweaking, like a rotating it, so it always stays straight after all this tweaking that they're doing. So if there's gravity, there's not. That's great, but you can put some gravity on it so it arcs down. The grenade launcher probably has that. Hit detection. So make a raycast hit. Go out, do a sphere cast. So we were looking at ray casts, but you can do shape casting. So a ray cast is a line, a nice thin little line, shooting out, seeing if it hits something. Sometimes it doesn't always solve all your physics scenarios. Sometimes, in this case, it wants a sphere casting. So it wants to know if it's hitting something bigger. So it probably wants to cast a sphere that's like the radius or something like that of the head, the tip of this bullet projectile. And maybe something like this. And you can see that this is a lot bigger than a line. And so the bullet, the laser bullet or whatever, is a little bit bigger than a line, and you don't want to like sneak through little spaces and like right next to people and you're like, hey, that's not fair, I definitely hit that enemy. It was just, you went through like a little gap in some of its section of colliders. So to account for that, we do a shape cast, or in this case a sphere cast. You can do other shapes. That's what a sphere cast means. It's just, let's not shoot out a line, let's just like draw out an object and see if that object hits something. All right, so for each hit that comes from this sphere cast, if it's a valid hit, which we covered already that method, this has to be true, and the distance that this hit happened has to be less than the closest hit. So basically, if you shoot out a ray cast or a sphere cast out a certain distance, you could hit multiple colliders. Could be, again, walls, floors, pickups, explosive barrels, players, enemies, what have you. So what we're doing is, okay, we just have a bunch of ray cast hits returned to us. Which one is the closest one? Because that's when we should be processing. Because even if I shot and I shot at a wall, behind the wall is the enemy, I shouldn't have hit the enemy, I should be hitting the wall. So we're like, okay, we found the closest hit, that's great. Now let's process it. Handle case of casting while already inside a collider. Okay, the point equals the root, the normal, flip it. So what it's saying is the bullet is moving so fast that between update frames, so if the bullet, and let me just grab the actual bullet. So if this prefab is moving so fast, right? Let's just say we're going to register a wall hit. So if we're lucky, the bullet like on the frame, it like just hit the wall or something. And hey, that's great. It's easy to process. But we have these situations where the bullet, like the next frame, the bullet's like well past the wall or inside a collider, not just about to hit it. We have to account for all those situations. And so that's what this is saying. It's saying, hey, if we're so close, so we're like that, we're gonna have problems processing it. It looks like they want to grab the position of the bullet, not the position of what we hit. And it looks like the normal is actually like our flip around, like behind us. So take wherever we're pointing and look behind us because we passed whatever we hit. So negative the forward. which we have access to back. Pretty sure there's like a back. I don't know why they didn't just, maybe there's not. No, there's a forward. No, there's not a back. My bad. Okay, so negative forward just means basically behind us, point behind us. All right, so on hit, and then pass in the point, the normal, and the collider. And at the end of the update, it's always important to notice, hey, look, wherever we were right now, we're at the end of our update cycle. We're going to remember that, and we're going to record it as our last position, because when we cycle through the next update frame, this will have been our last position. And we do that at the end. So on hit, I think I already kind of went through this, but we get the point, the normal, and the collider. It's not area damage. And whatever we hit, get a component on it. See if there's damageables on it. If so, we can call the method, the public method, inflict damage. Otherwise, the bullet, no matter what, if we hit the enemy or if we just hit the wall, the bullet's gonna shoot off a VFX, and there's gonna be some sound effects, and we're just gonna destroy the bullet. All right. So that covers both projectile hoverbot and projectile turret. Now, the player gets a weapon spawned from that like player weapon manager script. And so this is what the blaster looks like. We kind of went over this way back at the beginning. But we've got a weapon controller at the root. Some other smaller scripts I'm not really going to be going over. We got the muzzle point, the aim point, which is, this must be like the eye of the player up here. And deep down somewhere there must be some meshes. Okay, here's a bunch of the meshes. The meshes, remember these pistons are animating, and there's some VFX. We went over all these parts of it. So the core of it is the weapon controller, which we've already gone over the weapon controller script. And here, projectile blaster. So when this thing fires off, we're going to get a projectile blaster. And it looks like this. And it's extra long. It's the other one, it's just a different color and a lot longer than the enemies. And looks like the damage is racked up. Movement might be a little bit more. But if you notice, there's a projectile standard script on it. So, and then there's the mesh of the projectile and the tip of it. And so the structure of this projectile prefab looks just like the enemy prefabs, just some tweaks of it that I mentioned. So let's take a look at the launcher. So this is the grenade launcher, or disc launcher, and when it fires this projectile disc. This is very different looking. It's a disc, but still using projectile standard. But now the renderer is right at the top. Usually the renderer is down at child under. So damage area, projectile parameters, charged effects. Let me just projectile blaster. No, there's just one. I just want to see if there's other scripts. So what else is under here? Oh, we just have a VFX trail. So this one has projectile standard, and it might be a little different And that probably, yeah, gravity. Looks like gravity pulls it down. And it's probably, yeah, area of damage is projectile disc. Oh, sorry, damage area. So there is this one does have a area of damage, and it looks like it's another script. That's interesting. Let me just open this up real quick. Let me look at that property. Area of damage. Oh, okay, it requires damage area script too. Okay, cool. So there's another script here. So damage area. So this thing, area of effect to damage ratio. This is interesting. So this is a curve. So it's very similar to like VFX. If you're like setting a min and a max, or like you're defining this shape, and we can pick a value out over this shape, this curve. So notice it's an animation curve, and you'll see this a lot in the VFX. It's when this one happens to be defining damage ratio over distance. So notice like 100, like if you hit someone right up near you. I'm sorry. How far the impacted damageable thing is. So if the grenade explodes right on them, they're going to get 100% of the damage. And here it starts dropping down. If the grenade blows up, nearby the enemy, but starting to get a little further away, they're going to get like 0 damage. So this one just says inflict damage in area in a gizmo drawer. Okay. So one reference. So in projectile standard on hit, if there's an area of damage script, we're going to call the inflict damage in area. We're going to pass in all this, all these inputs. And so you got the damage, you got the center of the explosion, which physics layers, this query. Just don't worry about this. This is getting a little bit deep, but this is like the custom physics query being passed in, and the owner. So you've got create a dictionary with a key of a health script and a value of a damageable script, and create a new dictionary. Now create a collection of unique health components that would be damaged in the area in order to avoid damaging the same entity. Okay, so if somebody, an enemy or a player, whoever the opposite side fired this explosive, if it found like a whole bunch of colliders that were impacted, but they all happen to be on the same enemy, you shouldn't be like hitting them over and over again. So collider array, physics overlap sphere, computes and stores colliders touching or inside the sphere. That's interesting. So this one is not like a cast. We're not casting out a sphere or a line. This is just saying, hey, I'm going to place a sphere at this position with this size, this radius, with these layer masks, these type of physics layers, this query, whatever. And you're going to tell me which colliders are inside or touching the sphere. And then for each collider that was in here, we're going to go through and see if there's a damageable component sitting on that same game object that had that collider. And if it exists, then we're going to get component in the parent. We're going to go up from the damageable and look if there's a health script. Grab it. This is very unique. This is because the enemies have like colliders down in their hierarchy that have damageable, and then the health script is sitting at the root. So they're saying go up into the parent game objects, get me the health script. This is only for enemies. And so if there's a health script and Okay, so this is actually good to cover. So they're using a dictionary in a little bit more of an appropriate way than last time we saw a dictionary. So what this is saying is we have a dictionary, and a dictionary is a collection of objects, but it's not like a linear collection. It's not like a list or an array necessarily. Normally, what it is you have a key. It has to be of some type. And the key is whatever. It doesn't matter. It doesn't matter if it's an int, a bool, or something like health, whatever. It's something that you could reference and be like, oh, I found a health thing. I'm going to be coming upon health things a lot, and I want to use them as my key because I'm going to be getting access to them, and I want to see if they're in my dictionary, as opposed to say damageable here. So the way that they're using the dictionaries are saying, hey, okay, we found this health script that's on this one of these damageable colliders that we just kind of found in our area of blast. And now we want to check, is that health script in our dictionary? So this is the dictionary name, the variable name, dot contains key, so it's a method, and you pass in the reference. It's a reference to a health type. And you want to say, hey, does this dictionary contain this key yet or not? And if this will return true if it has the key. And so you want to say false, it doesn't contain the key, and you want that to be processed. So it's like saying, okay, you want to say, is this key, this reference to this one health component, is this already added to our dictionary as a key? And it's going to return, if it returns false, meaning we haven't entered it into our dictionary yet, this will return false. We negate it, we not it, so that it becomes true. And then we say, hey, if there was a health script on this damage component and that health script does not yet exist in our dictionary, then that's great. We're going to go into our if statement and we're going to add it to our dictionary. So this is the beauty of dictionaries, is that you don't need to loop through like a list or an array. You have to like loop through and be like, wait, does this thing exist yet in my collection? And how do you know that? Well, you have to go one by one by one by one. You have to loop through the array, the list from start to end until you stumble upon it. And if you don't stumble upon it, you have to go through the whole collection to know if it exists or not. So that's not very processing efficient, right? So that's why dictionaries are used. They're used all over the place, not only in game dev, but like dictionaries, which the more like rudimentary idea of a dictionary is called a map, a mapping from one thing to another, just like an enumeration is a mapping of a string and an int, or a collection of string and ints. So a dictionary is much more elaborate, much more robust of a mapping. And the beauty of a mapping is if you specify what your keys are, you can look up a key in constant time. You do not need to move through a whole list, a whole array. You could just say, oh, I have this key. I have this health script. I just want to know if this is in my collection or not at constant time, at like instant time almost. And be like, here's this reference to this one health script. Is it in my dictionary? Is it a key? Because keys you can look up in constant time, not the values, only the keys. And then you can say, whoops, it's not in my dictionary yet, but I want to know about it. I want to remember this thing because I want to know if there's more than one. I only want to apply damage to the health script once. And so, it's not in your dictionary yet, so we're going to call the dictionary and say add. And when you add an element to the dictionary, the element must have a key and a value. And you determine what those keys and values are. So in this case, it's of type health script is the key, and of type damageable is the value. And once you know the key, you can look up the value at constant time, because once you know the key, it's very easy to just jump in and get the value. So it's being, we're not going to go into other data collections. Just to be aware that other data collections might be graphs, trees, heap maps, heaps. And so what we did cover in this class are arrays, lists. And lists, you could think of single linked lists and double linked lists. We just kind of went over a single linked list, I would say. I'm not sure what a list is implemented behind the scenes. But there are singly and doubly linked lists. And I went over stacks and queues, which are like specialized lists. It depends how you pop off an element when you want to take it off. And dictionaries. Dictionaries are insanely used everywhere. And so just get used to them, because what the real trick is, like you see here, you can check if a key exists or not at constant time. You can add to it at constant time. You can grab the value of a key at constant time and remove. And these are much more efficient for these type of situations than the linear collections. The linear collections being array, list, stack, queue, because stack and queue are like specialized lists. Cool. So once we go through and we add only the unique health scripts and do not have duplicates of health scripts, then we can apply the damage. So for each damageable, and so the way that this reads is, remember, this is our dictionary, right? Now, modern languages have gotten very liberal with the use of the for each and everything. So we're going to loop through, in this case, not the, we're not going to loop through the dictionary where we would receive the key value pairs. You can actually loop through either just the keys or just the values. Here, because what does it matter? We're just like looping through each element in the dictionary. Each element has a key and a value associated with it. But this is like saying, hey, I don't care about the keys. We're going to loop through all the elements, but just give me the values. And here we're saying, okay, so you know that the values are of type damageable. So we're going to list a variable saying, okay, damageable, type variable, just give it a name, just unique, damageable, whatever. So for each of this type of damageable variable that's in a collection, the collection being the dictionary.values, just go through the elements and just grab me the values. Then we're going to see the distance, vector3.distance, from wherever this damageable position was to where the bullet, the projectile position was. We're going to see how far apart they were, and that's the distance that we want. And then we're going to say, okay, damageable, inflict damage, the amount of damage that comes through. And then I'm going to cover this in a second. And then true. So true. So here we pass in the damage, whether it's explosion damage or not, a bool, and who the damage source is. So the owner is this, like the owner of the bullet, the projectile, which if it's the disc launcher, then it's going to be the player, because they're probably checking if it's self-damage or not within there. But back to here, damage, whatever damage is. Now this one's interesting. So damage ratio over distance, it's calling right into the animation curve. So that's fascinating. So you can evaluate. It's kind of like a lerp. But what you're saying is, hey, this is an animation curve. I don't know the details of it. Somebody is a designer, somebody set up the curve. You can add more points. You can place down points and manipulate this curve as you care to. But somebody made this curve, right? but it's in this nice little 0 to 1 box. It's almost like, that's what I'm saying, it's like a lerp because the t value is 0 to 1. We're going from A to B over the course of t, but it's not a straight line. It's not a lerp. It might be like a slurp where we're going along a circle edge, but you can do whichever you want. You can, that's the beauty of the animation curve. You can completely define the edge that you're going to run over with t. So evaluate this animation curve at, and notice evaluate says float time. The time that we should evaluate. We're only going from 0 to 1. T is time. So what is t in this custom lerp situation? Well, it's going to be distance, this distance that we evaluated here, from where we are, the damageable object, to the bullet. That distance divided by the area of effect distance. So that seems to be a float. It's a property. It's 5 meters. Area of damage. Okay, so this projectile, this disc grenade or whatever it is, it has a damage area. The blast radius is 5 meters. It can hurt something when it explodes up to 5 meters away. So then we see the distance, right? So if I'm standing there and you shot a disc grenade at me and the thing blew up right on me, it would be 0 over 5. We would be at t equals 0. And t equals 0 of this curve is right up here. We would receive 100% of the damage. Now, if the grenade blew up nearby to me, like 1 meter, 1 divided by 5 is 0.2. So we would be t equals 0.2, maybe somewhere around here. Pretty high impact, like 90, 95%, whatever. We're going to still receive that brute force. If we're at 2.5 meters away over 5, that's half the distance from the explosion. We're like around here. You know, the drop off is pretty slow. We're still going to get like 70% of the damage. You know, and then if we're like 4 meters away over 5, that's 80% away from the center. We're around over here. And that's like a 0.3 damage, 30% damage. All right, so that's how this animation curve is working, and how we do this evaluate method. So think of it like a lerp, but you can it doesn't need to be a straight line. You can kind of define your own. And these animation curves are used all over the place for inspectors. Cool. So that was damageable area, damage area. So projectile standard, damage area. And I'm pretty much winding down. Maybe I'll take a look at this thing. I don't even know what's happening here. But projectile charge like to me, parameters, it's just like a whole bunch of settings that other stuff is going to reference. So a whole bunch of public properties, on enable, get the projectile base, listen to the on shoot event. On shoot, you're going to go out and get the projectile standard, the child class of the base class, of the base class you're just listening to. So it's a little weird how they're using the parent-child class relationships. But anyway, if the script exists, get value. So get the initial charge. It's like grab the damage, the radius, the speed. Damage is a min-max float. Let me go up here for a second. Min-max float. This is like another class. All right, so this is interesting. Then I'm going to wind down. So notice that this class is not. So here's a struct. Here's a struct. Here's a struct. There's not even classes, and they're not even inheriting from mono behavior. This script actually doesn't even sit on a component. It kind of just sits in the project, and people can call upon it, instantiate from it as needed. create objects as needed from it. But here it created a min-max float, right? Which is this struct, but there's min-max color, min-max vector3, but we did a float. So it's a struct. There's no methods. There's a min, a property min, a property max, min-max, floats, and then get value from ratio. So this looks like a method, and it's calling it damage, get value from ratio. All right, it's not I said that it can only get constructors, but they may have updated, because this looks like a public method that you call on a struct, and it's not a constructor. It's not when it's being made. It doesn't have the same name. So it looks like you can have methods on structs. Get value from ratio. So we're going to pass in a ratio, and we're going to lerp the min to max to the ratio. Okay, so it's wrapping. Okay, it's just got a lerp in there. So we're just going to pass in a ratio, and there's already a min and a max been established. Let me just, I think the establishing happened okay, it happened here. So this is interesting when these are made public, and they're these structs. Notice as I open them up, they're the internal. So normally structs cannot be like kind of shown in the inspector because they're so customized. But if you make them serializable like this, system serializable, they will be exposed, or their properties will be exposed in the inspector. So this is where you're seeing damage. You're saying the min and the max. All these have min and maxes set. And so then all you do is you can call this method, pass in this ratio, and it kind of lerps. So this has to be between 0 and 1. It's like a fraction. And that you just lerp from A to B with the amount of t going from 0 to 1. So sure. So it's just setting up all these parameters, and then they must just be referenced. Oh, wait a minute. Let me go back down here. Okay. So what it does is, these all have to do with initial charges. Oh, okay. I see what you're doing. So this is with the charge weapon. It's a little convoluted, but you're passing in the projectile standard script, and then if it exists, you're getting whatever the initial charge was, and that's our ratio. So if you're like holding down your charge weapon and you only charge up to like 60%, then 0.6 is the ratio. So you're only going to get a 60% damage, a 60% radius of your disc effect, a 60% speed on your projectile, and so on. You'll notice this type of that's interesting what they did. And they like pulled out some logic from here. And that's most of the time it's good in software engineering. It's just when it gets a little bit convoluted, it's sometimes I feel like it's kind of shooting yourself in the foot, especially when you have to work with other people. But you'll see with software engineers, sometimes they like to I guess over-engineer would be one word, or generalize too much. Like they don't have a solution that fits well for the scope of the project. They're always thinking that this like my engineering solution needs to like be robust enough for like an enterprise level app. Sometimes it's a bit much, but you'll notice it's quite a bit in software engineering. So it's kind of good to get exposed to. In either case, that's more than enough to cover. So we definitely are good for this game, first person shooter, and we're good for this quiz on Friday.